Hello student, good morning. I am Dr. K.SINHA, Professor of Chemistry. Today I will continue from the last class. Last class I was discussing question, answer and explanation based on state of matter. I am discussing questions, answer, explanation based on states of matter. And up to question number 36, I have discussed. And questions are based on kinetic molecular theory of gases and deviations from ideal behavior. Now, up to 37 I have discussed. Today I will continue from question number 38. Now I will read the question. A gas behaves most like an ideal gas under condition of, four options are given. First, high pressure and low temperature. Second, high temperature and high pressure. Third, low pressure and high temperature. Fourth, low pressure and low temperature. Again, I am reading the question. A gas behaves most like an ideal gas under condition of, first option, high pressure and low temperature. Second, high temperature and high pressure. Third, low pressure and high temperature. Fourth, low pressure and low temperature. Just to think, you can answer it quickly within 20 seconds. Its correct answer is low pressure and high temperature. Direct answer. This is the condition to show an ideal gas. Then at this condition means low pressure and high temperature, gas will behave like ideal gas. And say third option C, that is the correct. Next question I am reading. Which of the following gases would have the highest RMS velocity at 25 degrees centigrade? Highest RMS velocity. First, oxygen. Second, carbon dioxide. Third, sulfur dioxide. Fourth, carbon monoxide. Just to think it, question is very good. All questions are important for IIT's mains, advanced and NEET. Just to think it. Again I am reading the question. Which of the following gases would have the highest RMS velocity at 25 degrees centigrade? Keep pen and paper with you. Sometimes it will be easy to solve the questions. First option is oxygen. Second option is carbon dioxide. Third option is sulfur dioxide. Fourth option is carbon monoxide. Just to think. After that, I will tell the answer. Its correct answer is carbon monoxide. Carbon monoxide. How? Now I am telling you. RMS velocity is equal to under root 3RT by M. 3RT divided by M. It means U is directly proportional to T. Under root T divided by m. But here you have to just compare with molecular mass. Then molecular mass is down. 3 under root 3 RT divided by m. Then you can tell that U is a proportional to 1 upon under root m. 1 upon under root m. Then all gases molecular mass you put and then you calculate. Then for all 4 gases you have to calculate. For oxygen molecular mass is how much? That is 32 O2 gas. And carbon dioxide how much? Then that is carbon 12 plus 16, 28. Then like that way for sulfur dioxide also you can calculate. Carbon monoxide also you can calculate. Carbon dioxide is 44, C plus 32, 12 plus 32, 44. And carbon monoxide is, that is a 12 plus 16, 28. And for this sulfur dioxide, 32 plus 32, 64. Then if you take under root for all, then you will get CO has lowest m and hence maximum this RMS velocity, because CO value is how much? Carbon monoxide, its molecular mass is only 28, other are more. Oxygen is 32, carbon monoxide is 44, sulfur dioxide is 64. Then carbon monoxide is only 28, and since the square root will be less in less, then when square root is less, correct, then 1 upon under root m, then that will be 1 upon under root m. M is only, you can say, less in comparison to all. Then what will happen? U will be maximum, means RMS velocity will be maximum. Hence correct answer will be what? Carbon monoxide. That is the option D. Option D is correct. Fourth option. Next question I am reading. The units of the van der Waals constant A are, first option, atm L square mole power minus 2. Second, atm L power minus 2 mole power minus 2. Third, atm L mole power minus means per mole. And fourth, atm mole per liter. Again I am reading the question. The units of the van der Waals constant A are, first, atm L square mole power minus 2. And second option, atm L power minus 2 mole power minus 2. Third, atm liter per mole. And D, atm mole per liter. Just to think. Its correct option is first option, atm liter square per mole square. This is the correct option. Okay. And how did this came? Then you know that a small p, correction term, p plus p, a small p. Then for that expression is an square divided by v square. Then from this expression you can get the value of a small a. A means van der Waals constant A, and then you will find that A is equal to PV square divided by N square, and after putting the value of all term means P, B and N square is there. That's why then you will get for the pressure ATM is there, and for the volume B square means L square, and down is N square means mole square, down is mole square. Then you will get its unit will be ATM liter square per mole square. Correct. And first option is correct. Now next question. The units of the van der Waals constant B, volume means correction term of volume. Now you have to tell the units of the van der Waals constant B are first atmosphere, second joules, third liter per mole, fourth mole per liter. Just to think, it is very easy. You can answer within 5 seconds direct by seeing the option. Again I am telling you, the units of the van der Waals constant B are first option atmosphere, second option joules, third option liter per mole, fourth option mole per liter. Just to think, you can answer quickly. Its correct option is option C. Option C, that is correct. And it's a very easy. Actually, volume terms, you have to add only volume terms is volume only. B plus small b. Here B you are writing for the correction term B. Then that will be also volume only. Volume plus in that volume only you are adding a small volume. Correct? Then that will be also volume, that is the liter only per mole. And correct option is C. Okay, means B is equal to liter per mole, because volume correction means here you have seen derivation time, expression time, that in correction term, that is the that volume is the volume of the molecules itself. Correct? Total volume. This volume of the molecules you are deducting V minus a small b, that is also volume, and then volume unit is liter only, liter per mole. Now next question I am reading. Alpha, V and U represent most probable velocity, average velocity and root mean square velocity of a gas at a particular temperature. Which one of the following relationship is correct? Again I am reading the question. Alpha, V and U represent most probable velocity, average velocity and root mean square velocity of a gas at a particular temperature. Which one of the following relationship is correct? First option, alpha is greater than U, U is greater than B. Second, U is greater than alpha, alpha is greater than B. Third option, B is greater than U, U is greater than alpha. And last option, U is greater than B, B is greater than alpha. Again I am telling here, alpha is the most probable velocity. V is average, and U is root mean square velocity. Then which one of the following relationship is correct? First option is alpha is greater than U, U is greater than V. Second, U is greater than alpha, alpha is greater than V. Third, V is greater than U, U is greater than alpha. And D, U is greater than V, V is greater than alpha. You think it, if you are can say formula of relation you are knowing, then quickly you can answer. There is a direct relationship between these three velocities. Already I have discussed. Now just to think and answer. Its correct option is U is greater than V, V is greater than alpha. Means option D. U means root mean square velocity is highest. You remember. Then root mean square velocity is greater than average velocity, and most probability is least. Most probable velocity alpha, that is the least. Hence U means here RMS velocity. Then RMS velocity is greater than average, and average is greater than alpha, means most probable velocity. Hence option D is correct. It is easy actually. And here one more thing remember, value wise, if you will compare all three, means alpha is to V, V is to U, then you will find alpha value is 1, V value is 1.128, and U value is 1.224. Correct? Alpha value is 1 and average velocity is 1.128, and U value is 1.224. U is highest. That's why U is greater than V, V is greater than alpha. This relation always you keep in mind. Always this question is asked in almost all exam. Now next question I am reading. The kinetic theory of gases predicts that total kinetic energy of a gaseous assembly depends on, first option, pressure of the gas, second option, temperature of the gas, third option, volume of the gas, fourth option, pressure, temperature and volume of the gas. Again I am telling one more time, reading the question. The kinetic theory of gases predicts that total kinetic energy of a gaseous assembly depends on, first option, pressure of the gas, second option, temperature of the gas, third option, volume of the gas, fourth option, pressure, temperature and volume of the gas. Just to think, you can answer it within 10 seconds. Just to think, already I have discussed. Its correct answer is temperature of the gas. Means option B. Option B. Okay. Kinetic energy of a gas depends on temperature. Okay. Next question. Actually, it's a relation many times I have discussed. Kinetic energy is equal to half mv square. You know. And kinetic energy directly proportional to T. Next question I am reading. Question number 44. The velocity possessed by most of the gaseous molecule is first average velocity, second most probable velocity, third RMS velocity, fourth none of these. Again I am reading the question. The velocity possessed by most of the gaseous molecule is average velocity, second most probable velocity, third RMS velocity, fourth none of these. This also you can answer within 10 seconds. It's a correct answer is most probable velocity. Name itself is clear. Most probable. Then its correct answer is option B. The velocity possessed by the most of the gaseous molecule is most probable velocity. The velocity possessed by most of the molecules is most probable velocity. You remember, not average, not RMS. Okay, most probable velocity. Next question I am reading, question number 45. The value of van der Waals constant A is minimum for first option helium, second option hydrogen, third option nitrogen, fourth option chlorine. Again I am reading the question. Volume of van der Waals constant A is minimum for first option helium, second option hydrogen, third option nitrogen, fourth option chlorine. Just to think it. This also you can answer very soon if your concept is clear. All this question I have discussed. Just to think. Its a correct answer is helium. Option A. That is the correct. Why? A is a measure of intermolecular forces. A small a is a measure of intermolecular forces of attraction, which are minimum for helium. Correct? Van der Waals constant A it tells about intermolecular forces of attraction. Then in helium it is negligible, minimum. Now next question I am reading. The molecules of which of the following gases have the largest mean average kinetic energy at 250 degrees centigrade? Option 1 AR, argon, B CO, carbon monoxide, third helium, fourth all have the same kinetic energy. Again I am reading the question. The molecules of which of the following gases have the largest mean average kinetic energy? Mean average kinetic energy at 250 degrees centigrade. First option is argon, AR, second CO, carbon monoxide, third helium, and fourth option is all have the same kinetic energy. This is the fourth option. All have the same kinetic energy. Just you think. This is also a very good question. Think it. After that I will answer. Here answer is all have the same kinetic energy. All have the same kinetic energy. Mean kinetic energy depends only the temperature of the gas. Okay. mean kinetic energy depends only on the temperature of the gas. Then gas temperature is here 250 degree for all. For all gas, temperature is fixed 250 degree. Hence, all have the same kinetic energy. Next question I am telling you. For H2 gas, the compressibility factor Z is equal to PV upon nRT is first option equal to 1, second option equal to 0, third option always greater than 1, fourth option initially less than 1 and then becomes greater than 1 at high pressure. Again, I am reading the question. For H2 gas, hydrogen gas, the compressibility factor Z is equal to PV upon nRT. Four options are given. Z is equal to PV upon nRT is, what is its value? It is given, four option. Z value is, first option equal to 1, second option equal to 0, third option always greater than 1, fourth option initially less than 1 and then becomes greater than 1 at high pressure. This question is also easy, just to think. Its correct answer is always greater than 1. Always greater than 1. For H2, Z is greater than 1. As it shows positive deviation only, that is the main reason. Positive deviation means greater than 1. Z is equal to greater than 1. Z is compressibility factor. Next question means its correct answer is option C. Next question I am reading. Certain volume of gas exerts some pressure on walls of a container at constant temperature. It has been found that by reduction of volume of the gas to half of its original value, the pressure becomes twice that of initial value at constant temperature. This is because, first option, the weight of the gas increases with pressure. Second, velocity of gas molecules decreases. Third, more number of gas molecules strike the surface per second. Fourth, gas molecules attract one another. Again, I am reading the question. Certain volume of gas exerts some pressure on walls of container at a constant temperature. It has been found that by reducing the volume of the gas to half of its original value, the pressure becomes twice that of initial value at constant temperature. This is because, first option, the weight of the gas increases with pressure. Second, velocity of gas molecules decreases. Third, more number of gas molecules strike the surface per second. Fourth, gas molecules attract one another. This is full of concept. Just to think. After that, I will tell the answer. Its correct answer is more number of gas molecules strike the surface per second. That is the option C. More number of gas molecules strike the surface per second. This is the correct answer. Okay. And here you should know that as the volume is decreased, pressure increased, because more number of molecules strike the surface per second. Number of molecules, those who are striking on the wall, that increases. Next question number 49, I am reading. Which of the following is not correct in case of kinetic theory of gases? First option, gases are made up of small particles called molecules. Second, the molecules are in constant motion. Third, when molecules collide, they lose energy. Fourth, when the gas is heated, the molecules move faster. One more time, I am reading the question. Which of the following is not correct in case of kinetic theory of gases? First option, gases are made up of small particles called molecules. Second, the molecules are in constant motion. Third, when molecules collide, they lose energy. Fourth, when the gas is heated, the molecules move faster. This is also, you can say, it will not take too much time. Quickly you can answer. It is a direct question answer. Just to think. Which one is not correct? Not correct, you have to tell. Its correct answer is when means a statement is wrong, but answer I am talking about option C is correct. When molecules collide, they lose energy. Okay, this is the statement is wrong. This is the answer actually. This is not correct. When molecules collide, they lose energy. This is not correct. Okay, other three are correct. Means gases made up of small particles called molecules. This is correct according to the kinetic theory of gases. And the molecules are in constant motion. This is also correct. And last option, when the gas is heated, the molecules move faster. That is also correct. This third option, when molecules collide, they lose energy. That is not correct. Hence, this statement put this option C is correct answer. Option C. Then now I am stopping only here. Next class again I will continue. These questions are very, very important for all exams, either for medical or engineering. Thank you.